Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today we will be exploring equilibrium of forces. Before we proceed, let's quickly recap what we learnt in our previous lesson. In our previous lesson, we explored the examples of simple harmonic motion. We also identified some formulas for simple harmonic motion. We went further to understand the relationship between period and frequency. And I hope you learned something. Before we dive in, let's look at our lesson objectives. In today's lesson, we will learn the meaning of forces, define equilibrium of forces, and explore resultant and equilibrant forces. Are you ready? Let's go. Now, let's understand what a force is. A force is a push or pull acting upon an object as a result of its interaction with another object. It is measured in newtons and has both magnitude and direction, making it a vector quantity. Force is the invisible push or pull that makes things move, stop, or change shape. For example, imagine pushing a cart or dropping a ball. These are examples of forces in action. There are two main types of forces. Contact forces. These are forces that act when two objects physically touch each other, like friction. Non-contact forces. These are forces that act on objects without direct physical contact, like gravity. Forces are everywhere, driving the motion and stability of objects around us. Now, let's understand what equilibrium of forces means. A body is said to be in equilibrium when the body as a whole either remains at rest or moves in a straight line with constant speed, or when the body is either not rotating at all or is rotating at a constant angular velocity. This simply explains that equilibrium means balance. An object is in equilibrium when the resultant force acting on it is zero. The forces acting on it are balanced, resulting in static equilibrium, which means the object is at rest. Dynamic equilibrium, which means the object is in uniform motion. Example: a bridge holding a car without collapsing. Forces from the supports balance the weight of the car. It's not too difficult. Next, let's talk about resultant and equilibriant forces. Now, resultant force is the single force that has the same effect as all the forces acting on an object combined. It determines the object's motion or lack of motion. It tells us if the object will move, stop, or change direction. When forces are balanced, nothing changes. When unbalanced, the resultant force makes the object move or accelerate. Example: in a tug-of-war game, the team with the greater force wins, creating a resultant force in their favor. Formula for resultant force. In the same direction, F resultant equals F1 plus F2 plus F3. The resultant force is obtained by adding all individual forces acting in the same direction. Formula for resultant force. In the opposite direction, F1 minus F2 minus F3. The resultant force is also obtained by subtracting all individual forces acting in opposite directions. They are measured in newtons. F1, F2, and F3 are the individual forces acting on the object. Now equilibrant forces. An equilibrant of two or more forces is the single force, which will balance all the other forces taken together. It is equal in magnitude but opposite in direction. The equilibrant force is what cancels out all other forces on an object, keeping it balanced. It's equal in size but opposite in direction to the resultant force. The formula for equilibrant force is F equilibrant equals minus F resultant. Here, F equilibrant is the force needed to balance all other forces on the object. It acts in the opposite direction to the resultant force, while F resultant is the combined effect of all forces acting on the object. It determines the net direction and magnitude of unbalanced forces. Negative sign. indicates the equilibrium force is in the opposite direction of the resultant force. Resultant force is experienced while pushing a car. If multiple people push a stalled car in the same direction, their combined forces create a larger resultant force, making the car move. Resultant force causes movement. It determines the motion of the object. On the other hand, equilibrium force can be seen on a hanging light. The tension in the cable resists gravity, preventing the light from falling. Equilibrium force prevents movement or maintains balance. Now, let us use the formulas to solve these problems. Example 1. 3 people are pushing a cart in the same direction with forces of 5N, 8N, and 12N. What is the resultant force? Solution. Using the formula. F resultant equals F1 plus F2 plus F3. Substituting the values. F resultant equals 5 plus 8 plus 12, which equals 25 newtons. The resultant forces. 25 newtons in the same direction. Example 2. 2 forces act on an object. F1 equals 12 newtons to the right. F2 equals 8 newtons to the left. Find the equilibrium force. Solution. First we calculate the resultant force. F resultant equals F1 minus F2. Note that forces in opposite directions are subtracted. Take right as positive. Substituting the values. F resultant equals 12 minus 8, which equals 4 newtons to the right. Now, find the equilibrium force. F equilibrium equals minus F resultant. Therefore, F equilibrium equals minus 4 newtons to the left. You're doing well so far. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Well done. You've done amazingly well following along with today's lesson. Let's take a moment to go through what we've learned today. Equilibrium means balance. Resultant force tells us if the object will move, stop, or change direction. Equilibrium is either at rest, static, or in constant motion, dynamic. In our next lesson, we will be learning more about equilibrium of forces.